Welcome to CodingCraft. In this video, we'll tackle Meta's boss fight puzzle, Level 3. We'll explore two solutions, starting with a brute force approach with pruning, and then moving on to the fully optimized Li Chao segment tree. Here's the full problem statement from Meta's boss fight puzzle, Level 3. We're given N warriors, each with their own health and damage per second. The boss has infinite health and deals a constant rate of damage. Only 2 warriors can fight, one in the front line and one as backup. The front warrior fights until they're defeated, while the backup attacks alongside them and continues alone afterwards. Our goal is to choose 2 warriors that maximize the total damage dealt to the boss. Now, let's see how we can approach solving this challenge. To make brute force feasible, we need to reduce the number of warrior pairs we consider. The naive O of n squared approach is impossible for 500,000 warriors. The key insight is that many warriors are dominated, weaker in both health and damage, and can never form part of the optimal pair. By discarding these dominated warriors, we can drastically cut down the search space. In practice, we sort warriors once by health and once by damage. Then we prune candidates. Keep a front only if its damage per second is strictly higher than any seen before, and keep a backup only if its health is strictly higher than any seen before. For each surviving pair, we compute total damage using the base term and the overlap term. This works well in practice, even though the worst-case runtime is still quadratic. Let's now look at the Python code that implements this pruned brute force approach. Here's the Python implementation of the brute force with pruning approach. We sort the warriors by health and by damage, and then prune candidates. For the front line, we only keep warriors with strictly higher damage per second, and for backups, we only keep warriors with strictly higher health. For each surviving pair, we calculate the total damage as the base term plus the overlap term. This pruning makes the algorithm much faster in practice. But when tested on the Meta puzzle site, it still failed 4 out of 24 cases because of time limit constraints. So while this solution is practical for many inputs, it isn't enough for the strictest test cases. Next, we'll move on to the fully optimized approach using a Li Chao segment tree. The brute force with pruning approach helps in practice, but it can still reach quadratic time in the worst case. To go further, we reformulate the problem. Damage contributions can be expressed as linear functions, which means we can use a Li Chao segment tree. This data structure efficiently stores lines and lets us query the maximum at any point. In our case, that point corresponds to a warrior's health or damage value. The process is straightforward. First, we sort the warriors. Next, we build functions that represent their potential damage contributions. We insert these lines into the Li Chao tree and query it to find the best possible overlap for each warrior. Finally, we combine the result with the base damage formula. This guarantees O of n log C complexity, where C is the range of possible health values, up to 1 billion in this puzzle. And unlike brute force, this solution passes all of Meta's test cases. Here's the implementation of the Li Chao segment tree. The structure maintains lines of the form y equals m times x plus b and allows us to query the maximum value at any given x. It supports adding new lines and querying efficiently in logarithmic time. Since the health values can go up to 1 billion, this data structure is essential for handling such a large domain. The full code, including the wrapper function, is available in the GitHub repository. On the next slide, we'll look at how the segment tree is used to compute the maximum damage dealt. Now let's see how the Li Chao segment tree is applied in the solution. We perform 2 scans, one from left to right and another from right to left, so that each warrior is paired only with others, never with itself. During each scan, we query the Li Chao tree to find the best possible overlap for the current warrior and then insert its own line into the tree for future queries. After both scans, we combine the results with each warrior's base contribution, that is health times damage, and track the overall maximum. Finally, we divide by the boss's damage rate, B, to produce the answer. This fully optimized approach runs in O of n log c, and unlike brute force, it passes every single test case on the meta puzzle site. Let's recap. The brute force with pruning approach gave us a practical speedup, but it could still hit quadratic time in the worst case. By reformulating the overlap terms as linear functions, we used a Li Chao segment tree to achieve O of n log c complexity. This fully optimized solution passes all test cases, even for 500,000 warriors. The full code is available in the GitHub repository, and you'll find more clean coding solutions here on the CodingCraft channel. Thanks for watching, and don't forget to like and subscribe if you'd like to see more puzzle explanations like this one.